This video then follows on from the distance and displacement video that has been done, and this one is all about speed, which is the scalar, and velocity, which is the vector. So speed, it does not involve a direction, just like distance, it is a scalar quantity. Something to point out as well is the speed of an object often does change. Think about when you're driving in a car, you'll speed up, you'll slow down, it's rarely the same, it's rarely constant. However, we can assume it's pretty much constant at times. So typical values for walking that you need to be aware of. Walking, you'd walk at 1.5 meters per second. Running is about double the speed of walking, so 3 meters per second. And cycling is about double the speed of running, 6 meters per second. So remember what walking is, double it for running, double it again for cycling. 1.5, 3 and 6 meters per second. And of course, it's worth pointing out that it does change, and that might depend on the terrain, the fitness level of the person, etc. As a quick comparison, the speed of sound in air is a lot faster, 330 meters per second. So sound travels 330 meters every second. Linked to this is an equation that you need to know. Speed equals distance divided by time taken. If distance is measured in meters, time measured in seconds, distance divided by time, m divided by s, gives you m/s for speed, meters per second. If you're wanting to use shorthand, speed is given the symbol v, distance, unhelpfully, is given the symbol s, and time is little t. So v equals s divided by t if you wanted to use the shorthand version of the equation. I mentioned earlier that speeds may change, and that's also known as non-uniform motion if we're being posh. So the equation can then change to the average speed is then the total distance divided by the total time that's taken. In essence though, it's the same equation. So that's speed. Now on to velocity, which is our vector quantity. Well, all I've done here is change a few words. Rather than writing speed, I've written velocity, so velocity equals. Rather than writing distance, I've changed it to displacement, so displacement divided by, and then time taken. But notice the symbols v equals s divided by t remain the same. Velocity and speed are pretty much the same, but there is a difference. With velocity, you need to state the direction, so forwards, backwards, up, down, left, right, often given with a positive or a negative value. For higher tier students, you also then need to know about this other difference. One other difference is if you keep your speed the same, so let's say 2 meters per second, but go around in a circle. So your speed is the same, it's constant, but you're changing your direction. And if you change your direction, officially, you're then changing your velocity, even if the speed is staying the same. So the speed is not changing when you go around in a circle, but the direction is. So we would officially say that the velocity is changing. And then in a future video, we'll find out a bit about acceleration. So if the velocity is changing, you are therefore accelerating. So when you go around in a circle, you're actually accelerating. Time to quiz yourself. So press play and pause as you wish to continue through the next little while. So what is the equation for speed? Press play to continue when you're ready. So speed equals distance divided by time. Next question. What is the speed for a typical person walking? And if you remember, that was the smallest value, so 1.5 meters every second. Next question. What is the speed for a typical person cycling? So if you remember, it was walking, running, cycling. There's your clue. So that was the last option, so 6 meters per second. Next one. What is the speed of a typical person running? That was the middle option, so 3 meters per second. Next one. A conversion question, so how many meters are there in 1 kilometre? So there's 1,000 meters in a kilometre, so K for kilo always is 1,000. And then for students studying the higher tier, how can the velocity of an object change even if the speed stays the same, is constant? And if you remember, that's when you go around in a circle or just change your direction but keep the number, the speed, the same. As ever, I hope you found that useful. If you want to press the subscribe button, you'll then get alerted for any future videos that are made.